Understanding ANOVA, analysis of variance. Analysis of variance, or ANOVA, is a statistical method used to compare means across three or more groups. ANOVA tests whether there are significant differences between group means by analyzing two types of variance: between group variance and within group variance. Let's visualize how ANOVA works with a simple example. Consider three groups of test scores from different classrooms, each using a different teaching method. ANOVA helps us determine if the differences between these group means are statistically significant. One key advantage of ANOVA is avoiding the increased risk of error that comes with performing multiple t-tests. ANOVA tests the null hypothesis that all group means are equal against the alternative hypothesis that at least one group mean differs from the others. ANOVA works by partitioning the total variance in the data into two components: the variance between different groups, which captures the effect of the independent variable we're testing, and the variance within groups, which represents random variation or error. The total variance in our data equals the sum of between-group variance and within-group variance. In the next section, we'll look at how the F statistic helps us interpret ANOVA results to determine if observed differences are statistically significant. The F statistic is a fundamental component of ANOVA, representing the ratio of two types of variance. Between-group variance measures how far each group mean is from the overall mean. This captures the systematic differences between groups. Within-group variance measures how spread out the data points are within each group. This captures the random variation. The F statistic is calculated as the ratio of between-group variance to within-group variance. In more technical terms, F equals the ratio of mean square between groups to mean square within groups. These mean squares are calculated by dividing the respective sum of squares by their degrees of freedom. The F value helps us determine whether the observed differences between groups are statistically significant. ANOVA results are typically presented in a structured table showing the sources of variation, their sums of squares, degrees of freedom, mean squares, F value, and P value. The table header shows each component we calculate in ANOVA. The between groups row shows variation explained by group differences. In this example, we have an F value of 15.06 with a very small P value of 0.0001. The within groups row represents variation due to random differences within groups. The total row gives us the total variation in our data. ANOVA is used to test specific hypotheses about group differences. While ANOVA tells us whether differences exist among groups, it doesn't specify which groups differ from each other. Let's apply our understanding to a practical example investigating whether three drug treatments affect patient recovery time. Here we have data showing mean recovery times for patients receiving three different treatments. After performing ANOVA, we get an F statistic of 15.06 with 2 and 39 degrees of freedom and a p-value of 0.0001. Since the p-value is less than 0.05, we reject the null hypothesis. This means at least one treatment has a significantly different effect on recovery time. To determine which specific treatments differ, we would need to conduct post-hoc tests. This concludes our exploration of the F statistic and interpreting ANOVA results.